Hi folks, so in this video I just want to run through an example of how we can use a geometric series to model a situation similar to the bouncy ball problem in the last video. Okay, so suppose you are now focusing on building your upper arms, so that's your biceps and triceps, in a certain exercise program. Okay, makes sense. People often want to have bigger arms. Suppose that after your first week of following this program, the circumference around your arm, so you're measuring around it, increases by say 3 millimeters. Let's assume then that as you keep going, every week the circumference gain is 95% of what it was last week. Okay, the question is, assuming that this is reliable and sustainable, how much bigger will your arm be after 10 weeks? And I guess let me emphasize this: how much bigger than when you started? So not just than when you started. Okay. So we wanted to figure out the total gains that you've made week after week. Okay. So this is indicative of a series. So we can actually model this again because there are only 10 weeks here. We can actually write it out pretty quickly. But even if it wasn't, even if it was like 1,000 weeks where you wouldn't, there's no way you would write out 1,000 terms. I think it's still helpful to at least write out the first couple terms so you know what you're dealing with. Okay, so I'm going to do that. So on the first week, let's create a little table here. So on the week, we'll lay that across the top here, and then we'll say the gains, and I'll spell that with a Z because that's how awesome it is. Okay, so on week 1, we gain 3 millimeters, again in millimeters. Now, it says the following week we gain 95% of what we gained last week. So in week 2, I'm going to gain 95% of 3. And the way I calculate that is, well, I take that 3 and multiply it by 0.95. Okay, and that number is whatever it is. To get to the next week, then I take whatever it was before and multiply it by 95% again, which would be 3 times 0.95 squared. And this is going to carry on all the way through. And so where are we going to stop? Well, we're going to follow this through until we get to week 10. And then we get to 3 times 0.95 to the 9th power. So be careful here. Again, realize that this is always one less than the actual week here. Okay. This is and then hopefully this looks similar to what we did with the formula, when we derived the formula in a couple videos ago. Okay. So what are we actually calculating? Well, first off, we need to see what type of series this is. And we're trying to add all these up, plus, 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 all the way through. So we are evaluating a partial sum of a series. So we're going to evaluate from, let's say, n equals 1 to 10. There's no reason to make it anything else, just to keep it nice and simple. Our series is 3, and our common ratio, that's our first term, and our common ratio is 0.95, again, to the n minus 1. Okay. Again, I'm just making these terms here, make sure they fit into this table here. Okay, that's how I've kind of settled on this. So the 3 is always there, and that power on our common ratio is always 1 less than whatever n is. Okay. So again, we're adding up 10 terms, and the first term is 3. So to do this, again, we're going to use our handy-dandy formula, where this is going to be equal to the first term times 1 minus our common ratio raised to the number of terms, whatever that is. In this case, it's 10. All over 1 minus our common ratio again. It's really just a matter of plugging things in at this point. So this is just simply 3 times 1 minus 0.95 to the 10th power, all over 1 minus 0.95. That is often easily simplified to just, let's see, 0.05. At this point, you're going to just bust out a calculator and get an answer. So if I do this carefully, let's see, 1 minus 0.95 raised to the 10th power divided by 0.05 And I get, where's my pen here? Yeah, I get approximately 24.08. Again, check our units here. That's going to be in millimeters. So 10 weeks to add, 2.5 millimeter, 2.4 centimeters, which is about, a little less than an inch. In the grand scheme of things, not so bad, assuming that this is sustainable. Ready? So thanks for watching. Hopefully this helped. And if you are having trouble, seeing where we could apply geometric, this formula for a partial sum of a geometric series, definitely, I think, a relevant example. Thanks for watching, and I'll catch you later.